Hello friends, welcome to the VLSI design course. So in previous lecture we have covered the 8 to 3-bit priority encoder. So we'll continue this session. Now we'll write a VHDL code for the decoder. So to write a VHDL code for decoder, first of all we'll try to understand the concept of decoder. The name decoder means to translate or decode the coded information from one format into the another format. So a binary decoder transforms one bit or one n-bit binary input signal into a equivalent code using 2 to the power n output. So for example, we have 2-bit information, 2-bit input binary bits, so it will create a 2 to the power 2 total 4-bit output. So let us take an example of 2:4 binary decoder. So as I said, there are 2 inputs and 4 outputs, and its truth table looks like this. When input 0 0 is there, so 0th bit it becomes logic 1. If 0 1 input value comes, the first bit out of 4 bits becomes 1. Like that, 1 0 comes, second bit becomes 1, and if 1 1 comes, the third bit becomes 1. So this is the truth table of 2:4 decoder, and for this now we are going to write a VHDL code. So again, this decoder we can write using when else as well as with the bit select. So let us write a VHDL code for the 2:4 binary decoder. So just go back to our ISE. Now again follow the same steps: file, new project, decoder, okay, decoder design, project name is decoder. Then next, other parameters like product category, family, everything we are keeping same. Then finish. So it will create a new project with the name decoder. So we are going to add a new source VHDL module. So decoder 2:4, okay, 2:4. Then next, so here we have to define the port details, so entity details. So here 2 input, so I will give D as a input, bus 2 bits, so 1 down to 0, and Q as output. So these signal namings we have used in our encoder design, so same we are following it. And the bus width is a 4 bit, so it is 3 down to 0. Next, finish. So this creates a predefined library declaration, then entity declaration like this: input 2 bit, output 4 bit, and here we have to write a VHDL code for the decoder. So again we are using the same conditional statement when else. So let's write Q as a signal assignment. So as per the truth table, when input is 0 0, output is, now here we are giving Q0 as a LSB, so output should be 0 0 0 1. So let's write it. So Q is a 4 bit, so we can write 0 0 0 1. This output will be assigned to the Q when D is equal to 0 0, okay. Else when input D is equal to, this is a condition expression, so D is equal to 0 0, then it assigns the 0 0 0 1 value to the Q. If it is a wrong, then we can write 0 0 1 0 when D is equal to 0 1. If this is also false, then next state is 0 1 0 0 when D is equal to 1 0, and the last condition, if all the above conditions are false, we can assign 1 0 0 0 when it is a 1 1, okay. So the decoder will function like this. when input 0 0, it will create output 0th bit is 1 0 1, first bit is 1, other bits are 0. When input 1 0 comes, the second bit will becomes 1, and if it is 1 1, this kind of decoded outputs will be generated. So let's save it and check the and compile it. So let us check the syntax. Okay, so this is okay. Then synthesize. Okay, synthesis also completed. So now we are not spending time on the simulation. This is the exercise for you people. So you continue the simulation. Now we'll move to the generation or creating a user constraint file to generate a bit file. Okay, so to create a bit file, now in this case we are using this development platform. So these switches are used as the input port. So 2-bit input means switch 1 and switch 2 can be used as a input, and this J14 is connected to P1 port. So this connection we are going to do. So indirectly through this port P1 connection we can access the internal signals of FPGA. Then J15 is the output LED header. So that header we are going to connect to the P4. So whatever the output signals, internal decoded outputs are coming in the FPGA, it is routed through this P4 and P4 to this J15, and these LEDs will behave accordingly. So let us create a user constraint file for this 2:4 decoder. Okay, so for this now we are using a shortcut method to avoid a very lengthy process. Right click, new source, here mention implementation constraint file, give the name decoder. Okay, so decoder.ucf, then click next, finish. Okay, so it will create a UCF file, a text file, and now here we have to write the command for that UCF file. Okay, so we are going to write a UCF file for the input D. So here D we have declared as a standard logic vector, a 2-bit bus. So for this D we are going to assign the switch 1 position. So input is a P1 header, so P31 is for the D of 1 bit, and D of 0th bit is P32. So let's write it. So here net, then signal length D of 1, so MSB bit of D location is equal to P31. Okay, then for D of 0, so 0th bit we are connecting to the P of 32. Similarly, now the output is a Q output, again it has a range 3 down to 0, so total 4-bit output, and these outputs we are going to connect to the LED. So LEDs are connected to these locations P141, 143, 138 and 139. So let's connect it. So I am just assigning here Q3, Q2, Q1 and Q0. So Q3 we are assigning to 141, then 143, then 138, then 139. Let's cross check it. 141, 143, 138 and 139. So 4 LED outputs we have connected. So here we have to just say save it and just proceed further for the generator programming file. So this will generate a bit file. So it has internal states like translate, map, place and route. So our bit file is generated. So this bit file now we are going to use it to implement on the development board. So this implementation we are going to see in our next lecture. Thank you. Keep watching the videos.